Hello everyone, my name is Claudia Marchand and my teammates are Jesus Rivas Escarcega and Brian Mata. And tonight we're going to present to you the Monitoring Tool PMO 2.0 IVVT plan. We hope you guys enjoyed tonight's presentation. I will be followed by Brian Mata.
Hello, my name is Brian Mata and I will start off the beginning portion of the presentation. Purpose. The purpose of our system is to improve project monitoring and control by using earned value analysis techniques to help increase efficiency, to have a better understanding of progress and participation, not only as the team but as an individual team member as well, to yield more accurate data for the team, manager, and customer, and to create a system that helps students or teachers involved in projects or capstones become more efficient. System overview. As stated in the previous slide, our group is trying to create a project that improves project monitoring, control, and have a better understanding of team progression and participation. Our current system is actually based off of the weekly schedule in Module 3. As you can see, it's just an Excel template with minimal features and does not have any elaborate functions on how the Excel sheet monitors the projects. The improvements to the current system that our group is working on is trying to achieve and yield much more accurate data representation for the team, the manager, the customer, as well as the individuals involved in the team, and will provide a better planning for future projects and create better visualizations that help give insight to the team's progress. The PMO team, which is Group 3, will be in charge of the development of the software and document the necessary information in order to build an efficient system that addresses the requirements specified by the customer and manager. System overview continued. As you can see in the diagram on the slide, the template is just a simple Excel sheet on which the user inputs different tasks. Each task is then assigned to a group member or a set of members who give an estimate on how much time they think it will take to accomplish a task, as well as how long it takes to complete the estimated task and when it's due. The member or members assigned to the task will then input the actual hours it actually takes them to complete the task and the date of which it was actually completed. This template is then sent to the manager on a weekly basis via email or through other platforms, which can cause a nightmare in terms of monitoring the different tasks available for each system, as well as the weekly schedules between different months. Documents integrated into the PMO 2.0 project. Below is a list of documents that were integrated into our system, PMO 2.0. We uploaded the defect log, the requirements verification matrix, the requirements backwards traceability matrix, also known as a bidirectional matrix, the failure mode effect analysis, the CBA, the risk matrix, the system requirements, the validation criteria for acceptance, the integration test plan, the BIT, the qualification test plan, and of course the CONOPS. Organization. This chart represents the roles of each member. Due to the number of team members in the group, each one of us was assigned 2 roles. Claudia assumed the role of team leader and quality manager. She makes sure the team or group does the tasks assigned and launches a successful system, as well as makes sure that the quality of our work is up to par. Jesus assumes the role of planning manager and process manager. He helps determine what goals are needed for the system to succeed, as well as what processes are needed to accomplish each goal. I assume the role of support manager and customer interface. My duties include helping with technical parts of the system and trying to decipher what the customer really wants in terms of requirements. Our master schedule. This This shows the amount of time each member spent on the various sections involved in the IVVT activities process. As you can see, we have put a lot of time into our system documents, primarily with our requirements backward traceability matrix, as well as our cost-benefit analysis, from which, based on our feedback, required extensive corrections due to misinterpretation of what the document actually is. Project VVT activities. The Project VVT activities are broken into project phases and documents that we worked on during those phases. The following phases are standard phases of any project: the definition, the design phase, the implementation phase, the integration phase, and the qualification phase, and finally, the post-development phase. Each of these phases contains several documents that are used as guides and milestones to indicate the overall progress of the system. For example, the system requirements were created during the definition phase, and once validated, are then upgraded to the design phase, while the component test plan and validation criteria plan were created during the implementation phase to help pave a way for the integration phase. Definition phase. The definition phase is the phase in which we consider the project in terms of a business and stakeholder needs. In this phase, we are closely discussing with the stakeholders and taking their needs and their problems to create our requirements. This phase is composed of the CONOPS of the system, which gives a high-level functional description of our system. After the CONOPS is reviewed, we create the system requirements, which consists of a short list of the entire requirement list. Once the system requirements were peer-reviewed, a final RVM was created. The RVM is needed in the definition phase because it is a verification of the final requirements identified. Considers the project in terms of a business and stakeholders' needs. Closely discussing with the stakeholders and taking their needs and problems to create requirements. VVT-MP generation. The VVT-MP document encompasses the strategy used to complete the IVV task within the time and budgetary constraints. This baseline is needed to help guide us throughout the progress of the IVVT activities. We created this document by reviewing the requirements gathered from our stakeholders and establishing a timeline for the IVVT activities. Concept of operations, or CONOPS, review. The monitoring tool PMO 2.0 is an Excel template based by either a sharing program, such as a cloud service or an email service. The characteristics of the Excel allows users to input data and in return can view if they met their estimated times and due dates, as well as the total amount of effort of each member. The Excel sheet also allows the teams to create a copy of the previous week and erase the data to start a new week. When the system is shared through Google Docs or Dropbox, the environment adds multi-person editing, history control, and commenting capability. In our CONOPS, what we want to do to our system is provide overall value to the template by creating automated interfaces and allowing simultaneous access as well as visual representation to appeal to the user to more than just a sheet with a set of values. System Requirement Specification Review, or SysRS. The system requirements were created by the team for the project to help identify the stakeholders' needs. Personal and peer reviews were conducted on the system requirements to ensure all requirements are constant, traceable, properly described, and unambiguous. VVT members use the system requirements checklist to perform both personal and peer reviews. Any errors or concerns were logged into the defect log during these reviews. Microsoft Excel was used to create and maintain the system requirements in this project. Above is a list of the top 13 requirements for our project. We had a total of 68 requirements identified.
And we create several defect logs. This one is for the CONOPS, and here basically is to show or to clearly specify are the errors or that we have in the different documents, and try to correct them. And for example, in the system requirements, uh, we found that some of the requirements that we listed was very ambiguous, and with the defect log we clearly found them and correct. So we created RBM, requirement verification matrix, and basically is to define in which stage we are going to verify a specific requirement. It could be in the implementation or integration design stage, and also it's important to describe here what kind of tools we need to perform that test. Also, the level of each requirement. It could be a component level, subsystem level, or system level. This is the table that we created. And for example, for requirement number one, that is the easy access interface, we are going to verify this one in the design stage, because here we can make some correction and it will be easy or less uh, expensive, or resource will be not that higher to perform that correction. The next is the design phase, and the purpose is to develop the technical concepts and architecture of the target systems. I'm going to talk and show you about mm, the risk table, the cost benefit analysis, the failure model effect analysis, the validation system design tools, the system requirements, the bidirectional traceability matrix. This is the risk table. It is a document used to identify and control the possible risk of a project. In our case, we are focusing on the risk of the requirements. Our table shows the requirements ID, the descriptions, the probability 1 to 5, the impact also 1 to 5, and a factor uh, that is derived from the probability and the impact. And also we have the mitigation plan and all the activities to 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 reduce the impact of that risk. For example, we have the risk number 1, and that is the don't com don't complete a project due lack of work or any technical issue. So here some of the activities that we can do is create a project plan in which we are reviewing all the tools that we need, tools related to the technical aspect of the project. Maybe we can hire some expert in a specific topic or technical uh, issue or review of the system, like the database or the server. Also, it's important to specify the person responsible for this activity. In this case, will be your team. Also, the deadline to do that activities. And we have several or more risk, and and activities related to them. The next one is the risk matrix. Uh, this matrix demonstrates the level of risk with the ex exposition factor color code by activity. The, the lower impact is the green, and we can accept that risk. Maybe an mitigation plan is not necessary. We can live with them. And the next one is the moderate risk that may cause some mm, harm in the system, and we must have a mitigation plan. And the last one is the red, the 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 risk that could affect in a high level the system. For example, maybe the documents of the users can be mm, recovery or are going to be lost, and we need some mitigation plans, some activities to reduce that, because if the data is missing, there will be a very uh, important complaint of the from the customers. So, for example, we must need a backup system to reduce that problem. The next one is the cost benefit analysis, and the main purpose is to illustrate what the requirement needs and extensive testing, and the difference between the BVT and the impact cost. So, for example, we have the risk in the first row, that is the access control problems uh, with a high severity, and the BVT cost is 300 against the impact cost, that is 600. So the next one is the failure mode effect analysis, or FMEA. Here we review the function of the system and identify their failure modes, the causes and the effects, and each function has a potential failure, and we must have a plan to reduce that effect on the system. Uh, we use action related to the severity, the occurrence, the detections, and risk priority numbers are evaluated. So this is the table for all failure mode effect analysis. We have the functions. The first one is the register. Some of the potential failure mode will be unable to register, and the effect of this failure will be dissatisfied individual. The user will be not happy with this situation. That's why the severity is very high. Some of the potential uh, failure causes could be a problem with the communication between the server and the database. The occurrence factor is a 3, uh, so it's likely to happen. And the next higher level effect will be uh, that the user uh, doesn't want to, or don't want to use again the system. So the RPN are 54 and are very high. The action recommended is could be a backup server for the user information. the person in charge will be the software engineer, and action taken would be another action, could be the testing the function once a month to ensure that everything is working properly. And with all these actions, we're going to reduce the RPMs to 36. So this is the approach that we use to make the analysis of the potential failures in our project. The next one is the system requirement bidirectional traceability matrix, and basically is to ensure that all the elements that we include in our system are related to one of the requirements. For example, we have the requirement number 1 that is easy access interface. So the system element necessary to perform this requirement is the code. So we have a specific requirement to include in this element, and there are some elements that were created to meet a specific requirement, and it's important to see the whole picture of the system. That is the reason we create this matrix.
Implementation phase. The implementation phase is used to start testing components. The purpose is to create the elements of the system. Each element should be verified against its design and then tested to ensure that its standalone compliance with its allocated requirements. The document is made in order to ensure proper testing on the software interface. For our case, it should allow for the team to evaluate the use of functionality and ease of use by evaluating scenarios that involve the use of the interfaces and to conduct simple test cases that the user is more than likely to encounter. This phase is composed of 3 things: the component test plan, the component test description, and the validation of acceptance criteria. The component test plan. The component test plan was developed to ensure the proper testing on the monitoring tool PMO 2.0. Just to provide a brief overview, the purpose of the proposed system is to improve a project monitoring control and to obtain a better understanding of monitoring team progress and effort. The improvements on the current system should yield more accurate data for the team, manager, and the customer, and overall, it should increase the better planning in future projects. The PMO 2.0 team should be in charge of the development of the software system and the documentation of the necessary information. That way we can build an efficient system that addresses the requirements that are specified by the customer. So in this case, the proposed system is based on an Excel file that is used with macros to accomplish the system's objectives. Overall, it should provide the descriptions, constraints, procedures, and methods to analyze the results. Listed below is an expected integration result sheet. It addresses the following items: the items that will be tested, the test criteria, and the expected result. For example, at the very top we have software integrity as one of the test names. For that criteria, it should be: the test shall try 5 attempts using a registered login. The expected result is that all items were successful, or there was 5 failed attempts. At the end of the sheet, the individual doing the testing can provide the actual result of the test and whether it passed or failed, along with the date that the item was tested. The integration test. The following is a chronological list of the integration test procedure. It is to be followed as listed in order to ensure that the test can be properly conducted and in order to ensure that we can provide reliable readings and results. Number 1, we need to ensure that the software is on a PC or Mac operating system. Number 2, we need to ensure the operating system has Microsoft Office. Number 3, we need to make sure they have at least 50 megabytes worth of hard drive space to save a file. Number 4, we need to make sure that there's macros enabled on Excel before starting the software. And finally, we need to run the software and start test in order to ensure a successful integration test. Validation criteria for acceptance. The purpose of this document is to identify the validation criteria for the software interface portion of the PMO tool 2.0 in order to ensure and validate that the system will meet the project's and stakeholders' established requirements. The results will then be presented to the stakeholders, upon which then the criteria will be either accepted or rejected. Validation criteria for acceptance. Continued. The table below is designed to illustrate the validation criteria that was formulated for the monitoring tool PMO 2.0. The variables that were identified were based on the system's attributes and based on the functional user's requirements. The table below lists the validation criteria that was identified by the users and stakeholders. Additionally, the validation criteria table is going to further depict the test results of the validation criteria that was identified. The overall results are then to be presented to the stakeholders for acceptance or rejection. This type of testing is intended to be conducted at a higher conceptual level than just simply unit testing, and should be focused on the inputs and generated results at the user level. For example, if we look at the attached test case log, we see that one of the items, or one of the test criteria identified in terms of data storage, is that the system has 100 terabytes of capacity. The individual filling out this test log would then write down the expected result along with the actual result, and then a pass-fail rating, and when this test was conducted. The integration phase. The purpose of this phase is to combine the system components or subsystems into one complete system. This phase encompasses a series of planning tasks and activities that bring the system elements together in an orderly manner while verifying that their relationships are in accordance with the system architecture. This phase is composed of two things: the integration test plan and the built-in test description, also known as the bit description. Performance testing. For the monitoring tool PMO 2.0, we felt that it was integral to ensure performance testing was conducted on our system. Therefore, an environment was created that will test the system reliability of the monitoring tool PMO. It is crucial that two factors be determined for this test. The two factors are how many users can access the monitoring tool at the same time, and number two, how consistent and accurate is the data that the monitoring tool PMO is going to be providing. In terms of the expected integration test results, the expected test will let us know if the database or Excel spreadsheet is being updated accurately and with real-time data that is input based on the number of users that have access to the database. This includes ensuring that the database considers the numerous roles and their respective access levels to the monitoring tool PMO Excel sheet. The bid assessment. This document will provide a step-by-step description in regards to how the test will be conducted and verifying that the proper functionality of the component is done at startup. There will be a pass-fail criteria that will be described in each step, and any incidents that occurred throughout the test will also be recorded. The test results will be provided by the system after the bid conducts its analysis. Overall, the objective is to identify and develop an alternate system option in the event that there is a failure in our system and that the PMO tool 2.0 is not able to successfully provide the latest, most updated and accurate monitoring data to the customer, as well as ensuring that the monitoring tool allows for multiple user access consecutively and without issues. Next, we have the qualification and acceptance phase. The purpose of the qualification and acceptance phase is to continue testing the system. At this point, we have a full system, and thus we must test the entire system. Included in this section is the qualification test plan. The qualification test plan. This document was developed in order to ensure proper testing of the monitoring tool PMO 2.0 as a complete system with the capability to detect any access failures or dashboard failures, and then to report the findings to the software engineer. Overall, it will provide the descriptions, constraints, procedures, and methods to analyze the results of the designated test. Some of the capabilities that will be tested are multi-user access, track logs and risks, different access controls, and ensuring that there's an interactive dashboard. While production is a very crucial aspect of the post-development in the IVVT process, we did not include this portion in our project since our project only deals with software. We did include, however, the production readiness review aspect since we do need to test the readiness of our software product. The post-development IVVT activities included in this phase is production, maintenance, and disposal. The production phase. The production phase includes a production readiness review. During this review, it needs to be tested whether the manufactured products, subsystems, and end systems created in early pilot runs meet all their specifications within a stable, statistically quality control process. During this process, it is important to keep certain risks and issues in mind, such as integration, system, logic, production engineering, quality assurance, and safety. The engineer may choose one of the following levels of validation: either no validation, a small sample validation, a large sample validation, or a complete validation. VVT Use Maintenance Plan. A use-maintenance VVT plan is going to be created to support the system through the longest life cycle phase, the preventive maintenance phase. This will be conducted in order to keep issues at a minimum and therefore repair costs at a minimum. Additionally, preventive maintenance will keep collateral damages to the customer and the system to a minimum. In this phase, modifications and product improvements could be implemented to update and maintain the system operational. During this phase, you conduct software and security updates. You're apprised of all technological advances that could potentially impact our system. And we also want to make sure we conduct diagnostic software and security tests. One of the phases that is often forgotten or disregarded is the disposal phase. In terms of our system, for the disposal phase, we want to make sure that our software program is completely uninstalled, or if any other company is interested in our product, we could outsource or sell our program to that company. I also want to make note that during the disposal process, every component of our system will be analyzed before disposal. Conclusion. Overall, this course has provided us with all the tools needed to ensure that the monitoring tool PMO 2.0 is an incredible success. The different concepts reviewed during this course have been applied and utilized accordingly to our system. From the definition stage to the qualification stage, all of the matters have been considered to ensure that a successful validation, verification, integration, and testing can be achieved with our system. This concludes our presentation. If you have any questions, please let us know. Thank you.